Let's draw the diagram for prism. So let me draw a prism over here. Let's say this is my prism. Okay. Let's draw it here. Let's name this prism as A, B, and C. Let's draw an incident ray here. So this will be incident ray here. A ray which is going and hitting the face AB. This is incident ray AB. Okay, incident ray. And let's draw the normal. Normal means perpendicular to the surface. Which surface? AB. So this is perpendicular 90 degree to the AB. Normal. At the point of incidence. This ray will go parallel to the base. And let's draw here our perpendicular here to the surface AC. And this refracted ray, this was a refracted ray. This is coming out on the other face as this. Since it is going from denser to rarer, it will bend away from them. This angle is called as angle of incidence. This angle is called as angle of refraction, R1 and R2. This angle is called as angle of emergence because that ray is emergent ray. So the incident ray is this one. The first ray is incident ray. In the medium, it is a refracted ray. And the ray which is coming out from the other face is emergent ray. So the angle made with the normal is angle of emergence. Now if there was no prism, the ray was supposed to go in this direction. This is what? The path of incident ray when there was no prism. So this ray was supposed to go in along this green direction. This is the future of this incident ray. Similarly, if there was no prism, this emergent ray was supposed to come from this side. Which side? This side. So these two green rays are called as extended incident ray and extended emergent ray. And the angle made by both, we call it as angle of deviation. And that is our delta. What is delta? The angle of deviation. Okay. Now let's take this angle as angle 1 and let's take this angle as angle 2. Let's call it as Q and R. Now we know that angle A plus angle Q and R is equals to 180 degree. Sir, why so? Because AQ and R is a cyclic quadrilateral, the sum of its opposite angles will be 180 degree. Now, if we look at the triangle Q and R, in this triangle Q and R, angle R1 plus angle R2 plus angle Q and R is equals to 180 degree. Now, if I substitute here, the equation 1 and equation 2, if you compare, right hand side both has 180 degree and Q and R is common. So what can we say? We can say that angle A must be equal to angle R1 plus R2. Let me repeat, if I compare equation 1 with equation 2, then right hand side both has 180 degree. One factor is Q and R, so the other factor must be equal. Angle A is equals to angle R1 plus angle R2. This is your equation number 3. Very important. We will make use of it later. Now, if you look at the diagram, angle I, that is equals to angle 1 plus angle R1. This angle is equal to this complete angle, vertically opposite angles. And angle E is equals to angle 2 plus angle R1. Again, vertically opposite angles. I hope this is clear. And delta is the exterior angle, so it will be equal to the sum of interior angles, angle 1 plus angle. Yes, this exterior angle is the sum of angle 1 plus angle 2. Now, How can you find angle 1? From the first equation here, angle 1 will be equals to angle I minus angle R1. And from here, angle 2 is equals to angle E minus angle R2. This is R2. There is a slight mistake. This is R2. Let's substitute this value of angle 1 and angle 2 here. So our del will become equal to angle I minus angle R1 plus angle E minus angle R2. Now this del will be written as angle I plus angle E minus angle R1 plus angle R2. Great. Now if we look at equation 3, R1 plus R2 is nothing but angle A. So we can substitute here del is equals to angle I plus angle E minus angle A. I hope this is clear. This is your del, angle I plus angle E minus angle A. This is equation number 4. Let's move to our minimum deviation condition. Minimum deviation condition. So minimum deviation condition will be, for minimum deviation condition, what are these conditions? Angle I must be equals to angle E. Angle R1 must be equal to angle R2, and that is angle R. Both are equal to any particular angle R. And del we will call it as dm. These three conditions are known as minimum deviation conditions. Let's use these conditions and substitute in equations. So if I substitute this condition in equation 3, from 3, angle A will be equals to angle R plus angle R. So angle A is equals to twice of angle R, and angle R will be equals to angle A by equation number 5. And if I substitute this in our equation 4, so from 4, del will become dm. I and E both are equal, so angle I plus angle I minus angle A. So this I can write it as dm plus angle A is equals to twice of angle I, or we can write it as angle I is equals to dm plus angle A whole divided by. This is our equation number 6. So what is the objective of this whole derivation? The objective of this whole derivation is to figure out refractive index. What's a refractive index? Sin I upon sin I. So let's substitute here I. So I is nothing but dm plus angle A whole divided by 2, and R is nothing but sine angle A by 2. This is called the refractive index of this prism.